Ladies and gentlemen, please welcome distinguished scientist and managing director, Microsoft Research Redmond, Peter Lee.
Wow, thank you all for being here, and I can only imagine the bigger crowd that are watching this over the web. Today actually is my 1-year anniversary, and so I thought that was a big deal, big day, but I guess it's been overshadowed a little bit by other events. It's really my great pleasure to introduce the founder of Microsoft Research and someone who actually has recruited me twice. Once 23 years ago at Carnegie Mellon University, and then he got me again here a year ago. Our Chief Research Officer, Rick Rashid.
Thank you, Peter. I always love it when the music is still going. You know, a major anniversary like this is really a time both to reflect on what's come before and how we got to where we are today, and also to look forward and think about the future. I was thinking as I was driving in today in my car, you know, what would have been my reaction if 20 years ago someone had come up to me and said, you know, 20 years from now you're going to be standing up in front of an audience and giving a speech, you know, to celebrate Microsoft Research's 20th anniversary. Probably my first reaction would have been one of pleasant surprise. The history of basic research startups isn't exactly a positive one for the most part. There's a lot of research labs that have been started over the last 20 years and have failed. And I think I would have been pleased to know that we had survived, we had succeeded in making it to our 20th anniversary. If you then have told me that we were going to be the #1 publishing institution in the field of computer science, I would have probably have said, okay, that's cool. We actually did it. Okay, that's great. It was certainly something that when we started Microsoft Research, when Nathan Myhrvold recruited me to start Microsoft Research, we talked about what we might be able to achieve. I don't think either one of us would have expected that we would be where we are today. Now, there we go. In the well, you can think of the sort of the beginning of Microsoft Research in some sense. It actually goes back to 1990. Nathan, who was in that video, wrote a memo to the board of directors, basically saying, you know, that he felt that Microsoft should invest in a basic research organization. And of course, Microsoft was really small back then. This was in the 1990s. We hadn't even really crossed $1 billion of sales until later that year. So this was a big step potentially for a small company to take. The board agreed and decided to make that investment. Nathan went looking for a director, eventually found me after a long courtship, finally convinced me to actually come here and start Microsoft Research. And that was in some sense really kind of the beginning. And I came here with a very simple idea of what I wanted to do. I wanted to take that academic research environment that I was familiar with from my time as a professor at Carnegie Mellon University and put it in the context of a software company, a technology company like Microsoft. I had a very simple mission statement. It's right here. We've had the same mission statement for 20 years. And it really embodies what we believe in our sense of values. It states first and foremost that our goal as an institution is to move the state of the art forward. It doesn't really matter what part of the state we're moving forward. It doesn't say anything in that first part of the mission statement about Microsoft. It really simply says, you know, our goal is to further research in the fields in which we work. Now, the second part of the mission statement, in some sense, is equally simple. When we have really good ideas, you know, our second goal is to make sure we get them into use, that we change the world with our ideas and with our technologies. And so the idea that we take our best ideas and we push them into our products as rapidly as we possibly can, that's important. Now, we can't do that unless we have great ideas. And so that's why the first part of the mission statement is the way it is. But once we do, we can get them out. But ultimately, what we're doing, it's really about the future. It's about making sure that Microsoft has a future. And if you go back 20 years ago to when Microsoft Research was founded, very few of the companies that were Microsoft's peers at that particular point in time are still here. Microsoft is, and I think it is in part because of the investments we've made in basic research over the years. So Microsoft Research has grown in a pretty substantial way over the years. I mean, we now have 6 major research labs at a number of advanced technology centers around the world. You see them listed up here. As Peter Lee was saying in the video that you saw at the very beginning, the sun really never sets on Microsoft Research. We now have labs pretty much every few time zones, starting at China and making their way around. In fact, this particular event has in fact been celebrated now, for the better part of a day, starting in our research lab in Beijing, China, and moving its way around to Redmond and Silicon Valley. We have over 850 researchers in computer science now, basic researchers, PhDs, working in the organization. And overall, the number of people in the organization is well over 1,200, which counts both the researchers, but also our research SDEs, our program managers, our support personnel, and all the other people that make it possible for us to accomplish the things that we do. Now, I said in my in that mission statement, that part of what we're trying to do is we're trying to come up with the great ideas, but we're also trying to make sure that those actually have an impact, that we affect the world in a positive way. And today, you look at what Microsoft does, and you're really looking at a lot of what Microsoft Research has done. Over the last 10 years, from 2001 to the present, Microsoft's yearly revenues have grown from roughly $25 billion to nearly $70 billion a year. We've added 8 new billion-dollar businesses. And a lot of that has been done on the back of ideas and technologies from Microsoft Research that has allowed us to enter into new businesses or to protect the businesses that we're in. In particular, you can look back over the history. Back in 1995, when the high price of DRAMs was threatening the launch of Windows 95 and Office 95, it was a critical technology for Microsoft Research that allowed the company to be able to ship Windows and Office and enter that marketplace with a very strong 32-bit product and really change the nature of the industry at that time. It was Microsoft Research Technologies that helped us get into the 3D graphics space with Windows and eventually into Xbox. It was Microsoft researchers and our technologies that allowed us to enter into the search business as a real business opportunity, and then, of course, to create Bing, which has continually gained market share since it was introduced. And it was Microsoft Research Technologies that allowed us to bring to market one of the most innovative and exciting new products, which is Kinect, which really brings real-time 3D computer vision, into the home in a way that everybody can use and everybody can enjoy and take advantage of. So we really had a tremendous impact. Now, one of the aspects that I think has made Microsoft Research successful has been the fact that we've had a really simple model of how we do basic research, and one that frankly seems to have been lost, I think, among other industrial research organizations. And that is, you hire really great people. You give them the freedom to do their work, to figure out what it is they need to do, to find those weak points in the frontier of knowledge and push on them. And you don't get in their way. You give them an environment in which they can be productive. You remove as much as possible the bureaucracy that many people associate with doing research. So you don't have proposals, you don't have budgets for individual researchers. You make it very simple. And you create a space where people can be as creative as they possibly can. You do that, you have the right people, you hire the right people, you get great work. And that's what we've done, and you can see the impact that all that has had over the years. Now, I mentioned it's both a time to look backward, but also to look forward. In the field of computer science, continually changes. New ideas, new technologies are continually pushing us forward. There are 3 areas that, as we've had this event around the world, we've been focusing on in talking about. One is big data, the fact that today we're able to collect, store, manage, and process astronomical amounts of information. And that's changing the way we're thinking about science. NUI, or natural user interfaces, it's really the notion that we're now giving computers the same senses that we have. They can see, they can hear, they can touch, they can feel. They know where they are. They know when they're being moved and when they're being touched. And again, that's changing the way we think about the way we interact with computing. And then sort of arching over all of that is a new understanding of what's called machine learning. The idea that we can process those large amounts of data to be able to analyze the information, to be able to make predictions, to extract and build models that help us understand the world or help us understand the problems around us. Now, I'm going to show off 3 different technologies that try to both highlight some of the things that we're doing with our product groups and how we're making an impact in these 3 areas, but also give you a sense of sort of what the future might actually be like. So the first one is actually a technology that was shown earlier today in Beijing. It comes out of Microsoft Research Asia. It's called Tiger. And it's an example of a kind of technology transfer that, frankly, for the most part, we don't tend to talk about a lot, because it's the kind of technology transfer where we're impacting the way a product works on the inside, not necessarily directly something that users can see, but they can feel the results and the impact it has on the company. So Tiger is really a technology that improves index serving and changes the way we architect our search service in order to both dramatically reduce its costs and to allow it to do things that it wouldn't otherwise be able to do. So please run the video of Tiger.
To keep up with the increase of the information and the website in order to provide better search service is obviously the job of Bing. At the same time, if you need to increase the cost of serving such big index size, the cost to business will be very, very significant.
The Tiger project is a collaboration between Microsoft Research Asia and STCA. The goal of it is to improve the efficiency of the Bing runtime serving system. This is a very good match to take a research and make a big impact on Microsoft product.
Tiger invents a new architecture for index serving. Bing is eager to use this new technology for their index serving infrastructure.
Tiger project is a great innovation and collaboration between MSIA and STCA. The idea is first researched and validated by the MSIA team, and then we join the engineering organization and really help us to push through some significant execution challenges. Through this kind of technology to dramatically enhance capacity, we're able to use fewer data centers that will allow us to dramatically reduce the cost over time.
Looking forward, we see there's even bigger potential for this new architecture.
So in Tiger, we not only look at improved efficiency, but also look at new ways of processing queries. And these new ways will enable scenarios where we can significantly improve the relevancy of the results seen by users.
The Tiger architecture can also be applied to other search problems, such as enterprise search within an organization, and this could also be very helpful for our other products.
Innovation is very critical for the success of Microsoft products. And by working with the researchers, we can bring new ideas and innovation into the products constantly. And that greatly improves the user experience of our products.
Microsoft Research gives a lot of flexibility for us to pursue individual research results, and also is a very good place to turn the research into real products.
Tiger is one of the best collaborations we've ever done. We look forward to many more Tiger-like collaborations between Microsoft Research Asia and STCA.
The most exciting feeling is to see those scientific discoveries in the lab that actually can benefit the hundreds of millions of users' life.
So again, that's a kind of technology where, that's the kind of technology that, again, we will often not talk about so much in the sense that it really goes into our products. It goes underneath the things that people ordinarily see. But it's an example of the kind of innovations that we're constantly driving into our product, from Microsoft Research. And it is also an example of how we're trying to change the way computing works in order to make these really large data scenarios be more successful. Now I'm going to switch gears and show you a different kind of innovation that's going on here in our research lab in Redmond. This is really in the natural user interface space. And you can begin to think about the ways in which we might be able to sort of let computing systems interact with us in a much more natural way. So I want to bring on stage Andy Wilson, principal researcher here in Redmond, to talk about some work he's been doing in really changing the way people could interact with computing. Andy?
Thanks, Rick. So it's amazing the progress we've made the last 20 years. I was just thinking I've been doing interface and perceptual, or work in perceptual user interfaces for almost 20 years. And I think that the first time I digitized an image sequence, I used a laser disc and a very elaborate computer-controlled Laserdisc player to read back each frame. It digitized each frame. It took overnight. Anyway, so we've made a lot of progress. And one of the things I think that's most interesting is the way in which natural user interfaces also has implications for display technology. And what I'd like to show you today is a project that we have in progress right now. It's actually done with Chris Harrison from CMU and my collaborator here, Hervé Benko. And it really challenges the notion of what is a display, how do we relate to it. Right now we're pretty much used to a rectangular display like this projector. What happens if we break down that notion? We've already seen some of this when we're thinking about touch displays and Surface. Now let's use some of the new technology we have with depth cameras, for example, to really explode the notion of a display and furthermore make it mobile. So let's roll the video. So this is a system we're calling OmniTouch, and it's basically a wearable computer that allows you to interact with projected graphics. And those graphics are projected on your hand, on a notebook, on the wall, and all sorts of different kinds of surfaces. And you'll notice that it's reactive to touch, so you can touch your hand and it tracks the hand position. It also gets hover state. It's kind of important. So we're using the depth camera to model the shape of the hand so that we can correctly project graphics onto the hand and also detect when you're touching. Here's just a little illustration of how some of the depth processing works. And so we're detecting fingers in 3D and detecting when the fingers touch the arm. This is what the prototype looks like today. It's almost comically huge at this point, but you can imagine very easily that this will be miniaturized over time. So we're using a Pico projector and the depth camera. This next section just basically illustrates some of the things that we're doing to explore some of the interactions. So we get an email. We click the button on there to look at the email. And one of the things we're exploring is how do we co-opt or use some of the available projection surfaces in your environment. So one idea would be to actually specify in your environment, point at the wall and draw a box where you want your email to appear. And then you can interact with your hand to dial the phone. Here he's specifying, this is Chris Harrison in the video actually. Here you can specify where to put the UI on this notepad. And then there are some other kinds of interfaces. You think about, once you break down the idea of a rectangular display, well, how do you do layout? What does it mean to have an application? Here we're just arranging buttons down the side of the arm, and then you're interacting with it with this scroll list. Here's sort of a traditional multi-touch interaction. And then we can support a QWERTY keyboard on the desk, right? So we sense when the desk is actually in view. We know the difference between the desk and the notepad, and so we can treat them differently. This just gives you a little bit of an idea of the precision that we're getting with touch and drawing. And so we can annotate this document. Now you notice things are a little bit swimmy there. That's definitely a research prototype. And the idea that we can split the UI on the hand and make that a little bit different than what's projected onto the wall. Here we have this palette of colors. And here's another illustration of that. We can bring up functionality in the palm of your hand. So here he's just setting the application. Here's another view of some of the image processing and how we can classify some of the surfaces that the camera can see. And we can move, say, from a public or to a private display just by looking at the distribution of surface normals along that depth image. So that's OmniTouch. And of course, I mentioned that this is the kind of thing that we see miniaturized. Maybe it's a kind of thing that's in a lapel or even on your some future Bluetooth headset. These kinds of things. So it's just, I think that's just really a taste of what we're doing. Of course, it's very preliminary work, and it kind of just gives you a hint of what we're exploring. So
thank you, Andy.
Thank you, Rick.
So I think part of what's interesting there to me is that you become the projector, right? You become sort of a computing affordance, and gives you kind of a sense of the kinds of possibilities that are being opened up now that we have real-time 3D computer vision, now that we have the ability to project display onto any surface from relatively small devices. So the last demonstration I want to show you comes out of our extreme computing group. And I'm going to bring Doug Berger, who's our director of client and cloud applications, out here to talk about some work that they've been doing, also kind of in the cross between the natural user interface, the cloud, and the technologies around machine learning. So Doug, you want to show that off?
Thank you, Rick. So I'm Doug Berger, and we're here to present a demo in the augmented reality space. I have Brandon Lloyd and Nikunj Raghuvanshi from my team here. Augmented reality is the blending of the virtual and the physical worlds, and it has the potential to be one of the key experiential revolutions of the 21st century. The AR, as it's called, has the potential to revolutionize education, entertainment, commerce, advertising, many, many areas. And the demo we're going to show you today takes thin, lightweight clients like phones or Windows 7 slates and offloads the heavy computation required to support rich, very powerful AR experiences to the cloud. So doing the physics simulation, 3D modeling, aggressive rendering, that's all done on remote systems, and then the bits are shipped to these thin, lightweight clients to give you a rich, immersive experience. So, Brandon?
Okay. All right, so in case you haven't seen augmented reality before, this is a simple system here, and what we're doing is we have a surface with an image on it. And when I put it down and I look at it through this tablet, you can see that there's these stacks of blocks being rendered on top of the image. Now what's going on here is as I move around, the camera on the tablet is taking a video feed. And the tablet is analyzing that video feed, looking for the image, so that it can figure out where it is in space relative to the image. Once it knows that, it sends that position to a remote server, which then renders the graphics, and that gets sent back as a video, which is incorporated on top of this image. Now, this is a collaborative environment, so Nikunj is seeing the same thing that I am, and you can see that he's starting to fire some blocks into the scene. They're falling over. I can also participate. We can have some collaborative destruction here. It's always fun. Knock down the Jenga blocks. Who can do it first? Maybe you got dominoes. Now, we're sharing this environment right here, but Nikunj could be in his own house with his own image, and we could still be sharing this experience remotely. So now I'm going to switch to a second demo. This is a medical imaging demo. What you're seeing is the upper torso of a human being, the skeleton. And this is a very large data set, and it's very computationally expensive to render. It's a full volumetric data. I can come in here and see some of the details. I can change from bones to skin and blood vessels and slice down through there and see all the details. You know, this is something that wouldn't be possible on this tablet alone, but because the rendering is taking place somewhere else and it's just being shipped down to the tablet, we can have this experience. And one of the great things about augmented reality is that we bring this rich graphical content into my environment right here on the table. And another great thing is that you have a really natural way of interacting and navigating and exploring the data. You can imagine a doctor sitting down with his patients, handing them a tablet, and they can immediately pick it up and start looking at the data without having to learn some complex keystrokes or mouse gestures or whatever. And he doesn't even have to be in the same location. He could be remote. Okay, so for the final demo, we have Doug step in front of a Kinect camera. Maybe he's in some other city. And we have a different kind of video chat. I can move around. I can see that we've got a fairly detailed model of Doug right here. And this is all being done with a $150 Kinect camera. So because the viewpoint isn't fixed, I can move around, and it makes for a much more immersive experience. This would be useful for something like, if Doug were trying to show me how to work on a car engine or some complex 3D thing, I can move around and see what he's doing from different points of view. We'd like to thank Phil Chow and his teleimmersion group for helping us out with that. So what we've shown you are some of the rich immersive experiences that are possible when you combine cloud computing with augmented reality. And it's really fun to think about what the possibilities might be in just a few years.
Great, thank you guys.
Yep.
Well, I think you can imagine some of the possibilities here where you take a device of this kind, put it in front of something that you're trying to understand, and it can actually use data from the cloud to label, show you the various pieces of it, maybe even show you the insides of it. So I think that's pretty exciting work. Well, as I said, this is a time to reflect. This is a time to look forward. Somebody asked me the other day, what would I expect, in 20 years, right? This is our 20th anniversary. What's the 40th anniversary going to be like? And I said, well, first off, I'm probably not going to be here, okay? Although, it's still possible. I mean, I won't be that old, but yes, I'm probably not going to be here except maybe, as a visitor. But I think more to the point is I don't know, and I don't think anyone here knows. And I don't think, no matter what scientist or futurist you want to talk to, they're not going to be able to predict what's going to happen in 20 years, because that's really going to be determined as much as anything else by not just the technologies we create, but what people choose to do with them and how they use them and how they integrate them into their lives and into their society. But at the same time, I think that it's going to be an exciting world. And my hope is for Microsoft Research is that whatever the world looks like in 20 years, whatever that future holds, that the underlying principles, the core values of the organization, the respect for investing in long-term basic research, the approach that we have to working openly and freely with researchers outside of Microsoft, the contributions we're making to the academic community. I hope that those things don't change, whatever the technology changes might be that lead to that point in time. Thank you very much. I appreciate talking with you.